just make a quick video of this problem that we went through in class today. So we have a certain fast food restaurant that makes a claim, okay, that the average or the mean wait time, okay, at a drive-through is 3 minutes. Okay. So when we see claim, that typically means that we're talking about a population, all right? And the thing that we're making a claim about is the average or mean wait time, okay? So that's the parameter, all right? When the parameter is a mean or an average, we're talking about mu. We're talking about quantitative data, all right? We make a claim that that wait time is 3 minutes. Okay, so even though it gave us a number, it's still really unknown because we're just making a claim that the average of all wait times is 3 minutes. But we're looking to validate or test if that claim is plausible or believable. All right, so then we're given some additional information. All right. We are given that a customer doesn't believe that claim and they want to conduct a test. And so the test that they conduct is they take a random sample of drive-through wait times, okay? They do that by taking 72 transactions. That's the thing that they're observing, okay? That's my observational units, the 72 transactions, okay? And we want to know the average mean wait time of those 72 transactions. And when we collect all that data, we find that it's 3.6 minutes. All right. So if I put that, and I summarize that down here, we have a sample that we've taken. All right. So a sample size of 72 transactions. N equals 72. That's my sample. I'm observing. Those are my observational units. N equals 72. All right. And the statistic that I'm interested in is the average or the mean wait time of those 72 transactions. And I calculate that. It's known. Okay. So when I calculate that, I get the average wait time of those transactions is my X bar is 3.6 minutes. All right, if I look at that from a data collection perspective, what I would actually be doing is, as a researcher, I would say, okay, let me collect my data. I'm looking at or observing transactions. I would have transaction 1, transaction 2, transaction 3, all the way down until I collected all 72 transactions. And then I would record here for each transaction, I would record a wait time. Let's say it's 1.2 minutes. Or it's 4 minutes, okay? Okay, there we go. Sorry about that. All right, let's say this one is 4 minutes. Let's say this one is 3 minutes, okay? Each one of these things that I write down is the data, okay? We're going to have 72 pieces of data, wait times. All right. And the way that I calculated this 3.6 minutes would be I would sum up all the X's, the 72 of them, right? There's going to be 72 wait times divided by 72. All right. And that gives me 3.6 minutes. So what I want to do is to see, well, how does this 3.6 minutes compare if in fact the actual wait time on average is 3 minutes? That's where I'm going to generate this distribution of statistics. And so in order to do that, and we're going to get into doing this later in the class, we're going to use this applet, okay? We want to see if the claim is plausible, all right? And to do that, we're going to generate 100 statistics by the applet. All right, so it says, what does each square represent? Okay, well, we want to create this distribution with a certain type of assumptions. The first thing that we're going to do, we're going to assume that the claim is true, whether it's pi or mu. In this case, it's mu. Okay, we have a claim that mu is equal to 3 minutes. Okay, so we're going to generate a bunch of X bars, assuming that the actual average time is 3 minutes. All right, we want to do it under the same conditions as what we actually observed. In this case, n equals 72. And then we want to repeat it a number of times. In this case, we're going to repeat it 100 times. So there are 100 squares. Okay, each square represents an X bar, okay, which is an average wait time of 72 transactions. And we're generating those based on the assumption that the actual average wait time is 3 minutes. All right, and so we see here that the center of the data is going to be at 3 minutes. And then we're going to get some other information up here. SD, we have standard deviation is 0.058. Okay, so 3.058 would be one standard deviation, 1 something, 3.2. We can carve this up into how far away the data is away from the center for my standard deviations. All right, so then if I were to say, okay, this is what it looks like, assuming mu is equal to 3 minutes. So then I'm going to look and say, okay, well, what did my sample say? My sample said, when I looked at 72 transactions, on average, it was 3.6 minutes. Let me go down here to look 3.6 minutes. 3.6 minutes is all the way out there. Assuming that the average wait time was 3 minutes, how likely would I actually see a sample that was 3.6 minutes? Not, in this case, I don't have any data points, okay? No X bars were 3.6 minutes. So we'd say it's not very believable that the average wait time is 3 minutes because this is what it looks like here. And no simulated sample statistics were at 3.6 minutes at all. Same thing down here. If I saw a statistic that was less than 2.8 minutes, I would say that's unusual, right? That's not in line with the actual being 3 minutes.